Hi guys. I mean, the data set, the problem statement that we have chosen is the direct marketing problem, wherein given a data set where we need to predict whether a particular customer will subscribe for a term deposit or not, basically. As part of the data, we have chosen the data sets where the volumes are like 41,000 and set is for like 10% of that. There are overall 20 features that we got. Of them, 10 are categorical and 10 are numerical. As part of the EDA, while we were doing, we come across sort of a data discrepancy wherein we have this column called P days. P days is nothing but where it is the number of days where the client has been contacted before in terms of getting the data across. What we have done, like in terms of previous days, 999 means it has not been contacted at all. Okay, and in terms of when it comes to previous means how many times you have been contacted. Okay, now if you have 999 over there, and ideally the previous has to be 0, but we came across that there are around 10% of the data we got it at a discrepancy in the data. Ideally, we wanted to have 999 and the previous has to be 0. But here we came across that the 10% of the data, it was incorrect. So that was the EDA which we came across on that bits. Couple of imputation methods which we have given two examples over here. If you look at this categorical variable, we have this unknowns over here, which we had to impute. Since the volume is very low, we directly took the mode of it. And since this is another way of doing the imputation was we had this categorical variable where the unknown volume was too high. We could not take the direct mode of it, so we'd gone a bit more logical way of doing it. We looked the education versus the job sections and then plotted those accordingly. Like, not taking the mode directly and imposing all unknowns to the university. Basically, we have gone with the job section and then imputed accordingly.
If you look at a job and you look at education, the job which had the highest number in terms of education, we imputed those unknown
values with that. When we tried to do the correlation between the variables, we came across that there were certain numerical variables which were highly correlated. So while imputing into the model, we thought that we had to merge them together, but probably during the model explanation we will come across this again. But these were the features which were highly correlated, like employee variation rate versus the price index versus the confidence metrics. They were highly correlated. So we had to come across with some logic to merge them together and pass.
Expressions, why are they correlated? Is it obvious?
It's like from a definition point of view, if your Eurobond is high, then the employee stability is very high in that instance. So they go hand in hand in that instance. That's the reason we can see the higher correlation in them. The EDA highlighted, I mean, the problem classified as to be a classification model problem. And then using the hot encode features, we did that. We either imputed and we using ORCAN, the unknown got removed automatically from that instance. All the numerical, we have scaled them. We didn't look into the outliers and all that stuff. And we have removed the highly correlated features, which was duration, which is highly correlated with your target variable. Probably we'll walk through the model, what we have built based on this. I'll hand it over to Karan to speak on that.
So we basically, just to reduce our work, we wrote 3 major functions. One for pre-processing the data, one to test various models, classifier models, and one to check the performance of a model that we would deploy. So after reading the data and just like after post EDA, after kind of normalizing it, we ran the different classifiers. What we did was we took five rounds of validation. So we broke it into 5 different samples and applied each of the classifier models to them to get an average, so that we get an idea of how much of variance do we have using the same model over multiple data sets. And based on that, we kind of took we had 2 options. The reason we were looking at recall very specifically was because if you look at the problem statement, it is defining if the if the user will subscribe or not. So you'd rather have false positive and reach out to more people than classify somebody as he would not buy the product when that person would actually buy the product, and it would be a loss of opportunity. So considering that, we went ahead with gradient boosting, and we ran the model fit. Our focus was mainly on the confusion matrix, so that we can, what I just spoke about, so that we have an idea of how many we predicted right, how many we are predicting wrong, and we were looking at the threshold to try and reduce this number, which is those that we are classifying as no, and reducing that number. And yeah, that's how we were parameter tuning. So we started off by doing, taking a baseline and first tweaking with the tree parameters, and post that, taking the best values and moving ahead, we went into optimization of that using.
So can you go slowly and tell me what are those values that you are tuning it at?
Yeah, so we started off with the number of samples, then we went ahead with a number of trees, leaves, and so on. So.
Okay. And we were getting the values over here for the best one. Okay.
So after we did that, we reached the final, like the best that came out of the parameter tuning, and that's the result that we got.
So where is it? Where are the best values?
Yeah. So for us, this is what we could land up with. We use the same on.
I have a question. So you have considered different thresholds. Can you go up a bit?
Yeah.
So what it is you have come up with these thresholds?
So we basically, like we discussed, that we wanted to reduce the numbers that we are classifying as no, even though they were yes. So we noticed that as we reduce it, we could reduce this number.
Yeah. So
But
if
the
you
rate
make
of,
zero,
yeah,
if you make the threshold 0, it's like everything will be classified as something else.
correct.
So where do you stop?
Okay, so this was again to get an idea. We did not find the optimum threshold,
How the difference was.
and mainly our worry, or basically where we got stuck, was that the rate at which this was reducing is way. I mean, we were calculating wrong yeses at a very higher rate, a much higher rate. So the cost of actually making those calls was way more than the reduced opportunity. So we would have to look at a model, or maybe another option where we could reduce the rate at which this decreases or increases actually, and this rate needs to be higher. So that's what our towards the end where we got kind of stuck. I'll just kind of move. So yeah, this is where.
I think you have about 40 seconds left.
Yeah.
Sure. So this is where we kind of reached at the trade-off. We realized 2 other things which were sub-learnings from it, that it was not the demographics of the user which we had mostly in the data, but more the market indexes that affected it, and it was the week and time of the year that the campaign was run that affected it more. Coming back to the question you asked, this is what needed work. The type 2 error that we got, we wanted to look at how we can reduce that. What we tried and did was actually we took that data set which fell under the type 2 error and did an EDA on it to figure out which was the feature that mostly correlated with what we were trying to show. And if we eliminate that from the model, will it affect our results is what we wanted to try and then optimize that kind of work. So that's where we reached. That's the references, and yeah, this was the EDA that we did for.
From a documentation point of view, we have done the Google Doc and we put all our thought process together, and that's why it's an appendix just to showcase what we have.
Yep.
These were the references that we had. I think probably we covered all those reasons.
So what are the results on test set? I'm sure that's it. Oh. You got some test trial as well.
Yeah, yeah.
So if you actually look at it, for some reason we fared slightly better on it. Not much, but yeah, it's almost similar to. That's the result of the essay. This.
But you're also fitting on it. You're
Oh,
calling-
okay, yeah.
So you're fitting on test set.
Oh, yeah.
Can you go to that part? Excel notebook, final project, notebook.
This part.
What exactly is going on?
Actually, a summary of that is this sheet here. So we've exactly. Okay. Yeah.
So what we have done, like, we have computed the age over here.
So you can explain the reasoning behind that.
That we already.
If you have any questions, you can ask as well. If you have any questions, you can ask us.
You guys have to read.
So where exactly is the EDA code? Is this the EDA code? Yeah, the code for the EDA in terms of doing the feature engineering, it was this. And initially, if you have seen the presentation that we covered on this thing.
Was it done over the Excel? So if you take some value, some random value, and feed it to your model, will it return the right value? Will it be tested? So for example, I take a mock-up data, I take mock-up one row, and I feed that to your model. Will it return the right result? That's what I'm saying.
We cannot predict if it was written right or not, but we as a single data point, we have not tried that kind of question.
Because you take a test set, a row from a test set, and you know the Y for it. You predict, you use your X, and then you predict your Y. Will it give the same result?
It all depends. We have written the model, but you cannot take single data point to feed into your model, right? You have tested and all that stuff.
So
Right?
that is how we would test our model, right? Essentially, even after we have checked our accuracy and scores, if we are able to give, because it depends on the recall, if the recall is higher, it will probably give you the right result. Is that not?
But imagine whatever data point which you took, it is not part of that recall positivity in that instance.
So I think they don't have result on a test set. That's
So for that part, we have covered while selecting the model. We have took random data points into each and every. That means we have run five times the model. We have run 5 times. So every time the data was random. So it was not consistent.
Well, on the train set or the test set?
On the train set.
that is the
That
splitting
is
part.
in the model.
So splitting was random. So
Okay.
it can be covered in
The
that.
only thing is that the test set we have to predict it.
Yeah.
We have
Yeah,
to
we have
predict
not done
it.
that.
So that was the only.
Okay, you can explain the how you're doing the.
Okay. So in this instance, age was a continuous variable for us, and for instance, we came across to the categorical on this instance, but it was an intuition. But before that intuition, we also gone with the job section. I'm not sure that it was covered as part of the EDA section, and then we did this logical grouping of them, and then we have come across of education, wherein it was like basic 4, 6, and 9. It was less than 10. It as good as you were having basic in that.
The idea behind it was to reduce the number of variables within a
Categorical
feature,
variables,
so
right?
that
See, so the moment you categorize a numeric variable, you're basically losing out on information. Okay?
No, these were the
In numbers,
categorical.
age.
Age one, yeah.
हाँ, so एज में लेट्स से आपने 17 से 23 के बीच में सबको एक कैटेगरी में डाल दिया.
Yeah.
So you are losing out in the variation कि 17 है या 23. So उन दोनों को सबको एक. And anyway using really good algorithm, gradient boosting आपने लगाया.
Yeah.
ठीक है. So what was the reason behind categorizing a numerical variable?
mean, it was again, as I said, major was from an intuition point of view. Like age cannot be going like in a, because age can be till 100, 110, something like that.
The, major reason we did it was, one is there were a lot of outliers on both ends, and second, we wanted to reduce the number of variables in each of the table, because we were going to hot end.
Number of variables are there?
I mean, within a feature, we would have had a continuous.
So आपने basically सारे numeric variables को categorize करा?
Not all of them.
So we have looked at the continuous variable section where we have seen the heat maps, the Eurobond 3 and the employee variation rate. They were all numeric in nature and they were highly correlated. That's where we came across to merge them together, because everything is highly correlated, it can improve the performance. That's where that was part of our future.
So इसमें खाली प्रॉब्लम ये होता है, एक तो वेरिएबिलिटी लूज होता है, दूसरा आपने इंडिविजुअल के हिसाब से ग्रुपिंग किया है। अभी आपको पता नहीं है कि ये सही में नेचुरल ग्रुप है कि नहीं।
That what we have done, we directly not gone with the age, like do this group and come up with this group. We have mapped this age to the job. And in the job we had retired and student. So when we probably, if we can open that.
Yeah, just open that presentation.
We have not covered as part of the example, but we have ran that into our like when you have age, suppose 7 to 23, why we came up with that? You had job description, it has student and retired. So when we have clubbed that together, majority of the volumes which are coming into, they were falling under the student bucket. When it's 7 to 23, okay. When it comes to 55 plus, all the majority of the records which we're trying to, they were getting categorized into retired only. So that was again you have matched with, not a purely you've gone with intuition, but we have mapped that across with the data set as well at your record level.
You're doing this, you also are introducing a correlation between the variables.
So basically basically आपने जो variable लिया which was job description, वो भी इंडिविजुअल से लिया ना, like you don't know कि वही सबसे ज़्यादा representative मेरा variable है।
Actually, because if you see from like a domain point of view, your job will be more intuitively related to your age. That is the only reason you will map it across.
So what you're trying to predict is what you're trying to predict is कि इस customer को मैं call करूँगा तो convert होगा.
Yes.
Right? Now you don't know कि is my current job description a very well influencer of that.
Yeah.
Correct. So हो सकता है कि मैं student हूँ या नहीं, मेरे को फर्क ही नहीं पड़ता कि मैं call करके convert होऊंगा कि नहीं.
Yeah.
इस केस में आपने student के हिसाब से classify कर दिया. So you are basically force fitting something which is not actually relevant. So ठीक है, इसको यहाँ पे कैप करते हैं. What you could have done is छोटा सा अगर ये करना ही था तो थोड़ा सा clustering करके देख सकते थे over.
Actually, the time which we have, probably the other way we wanted to, as you said, the age group logically grouping, we wanted to keep all those things when we are converted to categorical to keep as numeric as possible.
So
because 10, 10 was there, 10 and 10. What we have done of that 10, we have 3 converted to categorical. So the other point was like to keep 10, 10 as it is, and then see the performance, and then see 13 versus 7, how it is working. But given the time frame, it was actually not working on
No
that.
problem. Cool. Thanks.
Thank you.